Let's use ShapeCast to make a new mold for slipcasting. ShapeCast lets us take a 2D profile of our pot, and it automatically generates a bunch of 3D files that we can 3D print to pour plaster molds into. Basically, something like this is what we print. That lets us pour plaster molds that we can then slipcast and turn into our pots. This here is the ShapeCast webpage, shapecastmolds.com. The front's just a landing page. You can sign up, and once you sign up, you'll get access to some more stuff. There's a bunch of handles that are on ShapeCast. There's a bunch of pre-made vessels that I've made. So if you click into one of these, you can see the different information about the design. It has some size information, and you can download the files. You can download the 3D files as is and use them, just print them, or you can download the SVG and run it through ShapeCast yourself, either as is or you can tweak it. So let's go ahead and download this. So we can open this. So this is the SVG itself. This is the profile of the pot. And this is what I drew, but you can go ahead and modify this if you want. And the last thing that is new is this designs page. So I basically have completely revamped this. I've spent a good chunk of the beginning of the year reworking all of this, and it's completely new and different, and hopefully a whole lot better. So here are a bunch of designs that I've been playing around with, and we're going to make a new design. So we'll get a create our own mold. We'll choose the SVG file that we just downloaded. You can choose the SVG, and it gives you a 2D preview of this. You want to double check that your sizes are the same as what you intended, and I'll talk more about fixing that in a second. You can continue to the 3D preview. This is a quick rendering of what the pot will look like. If you don't like it, you can go back, tweak things, go back and choose a different SVG if you'd like. I'm going to continue with this one. Down here, it starts showing some of the parameters that have already been set. You can continue. Gives you a few instructions. Basically, it's going to go ahead and create a design proof. And the idea of the design proof is to do a quick check to make sure that we can actually generate the models. And it will also then let us calculate the volume of the pot, assuming a 4.5 millimeter wall thickness and 13% clay shrinkage. Next, you submit this to the server. This goes up to the ShapeCast web server and does a bunch of processing. Basically, it's taking that SVG and turning it into the 3D models that we're going to need. Depending on how busy the server is and some of the options you select, this can happen relatively quickly, or it may take a few minutes. All right, we got the design proof back. So it's estimated the volume as 362 milliliters or 12.2 ounces. We can download the proof. So inside of there, we got an STL. This here is the STL. You can go ahead and open this up, double check it, make sure it looks good. If it's a new design and you have a 3D printer, I do actually recommend go ahead and 3D printing it. I have designed several pots that after I 3D printed the proof, I actually didn't like them. So it saves a lot of the effort before going through the whole process. And you can go ahead and open this in your slicer as well. And as I said, print it out. The other thing you get is README. And at this point, really the README just gives you the size of the pot. All right, if you don't like it, you can go back, again, replace the SVG, change the sizes, whatever you want. Or if you think it's good, you can go ahead and improve it. At this point, you have an option. You can create the outer molds or not, yes or no. So the outer molds are these two pieces here, or four, depending upon the size of your printer and what you decide to print, as well as the bottom ring. This here is the inner mold. This is the one that basically dictates the shape of our form. The rest of this basically replaces coddle boards. So if for some reason you're not using the outer molds and you want to use your own coddle boards or a bucket or whatever, you can go ahead and select no. Otherwise, I do highly recommend using the outer molds. And it went ahead and put the volume down here so you can keep track of it. You can submit it. This will go back to the server and it will generate all of the files that we need to go ahead and 3D print. All right, so this took maybe less than a minute, and now we have a link to download our final models. So you see there's a bunch more files. We still have the proof that was there originally. We have the README. This has been filled in with information about how much plaster you're going to need, how much water you're going to need, and some instructions. We have the outer mold, half, and quarter. So depending on your print bed size, you can pick one of those. We have the bottom ring that will connect the inner and outer together, either whole, half where you would need 2, or quad where you need 4. and finally the inner mold itself. And that's it. That's running through real quickly what it means to go ahead and take a profile and turn it into the models you need to go ahead and 3D print to make your plaster. So again, you basically just take those, print them out, mix up your plaster, pour it in. Once it's set, you can demold it, let the plaster finish curing, and you're off to the races with ShapeCasting. So at any point, if you want, you can go back to the designs. This basically shows all of your designs. This is the one we just did. You'll notice there's a few options here. You can archive it or delete it. There are archived and deleted tabs. Right now mine are empty. If you had older designs that you made with ShapeCast before I made all these changes, they'll show up here. Eventually they'll disappear. So we can go ahead and archive this design. You can still download it. If you want to, you can unarchive it. Now it's removed from this list and it shows up over here. We can unarchive it. Or if you want, there's a little button up here to archive or delete it. Or you can do the same thing. You can archive or delete it. There's that one there. Got a couple of these. Let me go ahead and, I can delete this one here. It's disappeared. And it goes over there. So all the designs will disappear after 30 days, but this lets you kind of keep things cleaner than that long laundry list that used to be there. So one of the big changes I made was to go ahead and make this step-by-step flow, so hopefully it's a whole lot easier to use. Another change I made is I added a whole bunch more error detection. Before, when you uploaded an SVG that wasn't quite right, it would give you a short explanation, but that wasn't always easy to understand. I've made that a lot better as well. So we can make a new design, and we can choose an SVG, and I've made a bunch of errors here. So the first one is you have an empty SVG. So we open that up. Basically shows you a little graphic here instead of your profile. It says this SVG doesn't contain any paths. This, for example, is actually the template that I use. The template is intentionally empty. People sometimes try and upload the template as is, and they're like, why isn't there anything there? It's because it's empty. So you need to go ahead and draw your profile. So here's another one. So this is, let me show you the SVG. So this one here looks like it has a profile of the pot, but this actually isn't a line. This is an image. So if we go up here to say like the XML editor, we can see this is actually an image. ShapeCast uses SVGs, which are basically instructions that say start here, move this far forward, turn this much, go this much more, versus an image is basically a whole bunch of pixels. So while this looks like a line, similar to the other ones that ShapeCast needs, it can't interpret this. So now if you upload this one, you go choose the file, this one here, it basically gives you the same preview and it says this one only contains an image. And you need to be able to draw the SVG. So here's another one. This kind of at the surface looks okay. It's like, okay, here's the foot of the pot and here's the outside wall. Let's try this one. And it's giving you an error here. So this basically says that it's a closed path. So if you look, there's actually two lines here, even though our SVG looked like there was only one. So if we go over here, we can actually see that the fill was turned on. So if we turn the fill back off, we can see actually now there's two different paths here. So while this looks like one, this is actually a closed path and doesn't work. It also shows with this red circle where the start and the end of the path actually is. So that won't work. So you basically would need to remove one of those lines. Here's another one. This one looks very similar. And the preview basically shows something similar. It actually looks like there's two lines here, not just one, and it's all close together. So this one, we go over here to the fill. The fill is off. What happened is the stroke style is relatively big. So if I make this something smaller, 0.2, you can actually see again, there's two lines here. So these errors I think can be very confusing. It looks like there's only one path, but by turning the fill off or making the alignment smaller, you can actually see that it isn't what ShapeCast needs. The preview helps show this, and hopefully this will give you some hints in going back and fixing your SVGs. So here's another one. This one again is kind of the same shape, but you'll notice there's actually a gap down here. And I've kind of made this intentionally large, and the two different paths are different colors. So when we load this in, it basically says there's two paths found, but ShapeCast can only use one. So the circles again show the start and end of each segment, and it uses different colors to show them. So that one won't work. Here's another one. This one looks continuous, but as a hint, because they're different colors, they actually aren't one path. This is still two different segments. However, since they were touching, ShapeCast was actually able to join these together. So it can go ahead and fix some of these errors for you. Basically puts up this warning message that says, hey, we found a bunch of different paths and we combined them. Make sure this looks like what you actually want. Here's another one. This one's a very narrow pot. ShapeCast can't deal with this when it's too narrow, or likewise when it's too short. So this one, it says it automatically resized it because the rim was too narrow, so check your sizes. So basically it made it bigger. So here's another one. I'll get some of these. This is basically backwards. ShapeCast doesn't know what your pot's supposed to look like. It really is just following these lines kind of blindly. Humans are really good at identifying, oh, this one's actually backwards. Although there are valid designs that kind of sort of look like this, ShapeCast will give you an error. So the rim can't be too narrow, and it's basically complaining it won't be able to attach the flanges that we need. There are several other errors that kind of sort of look like this that aren't actually backwards. So this SVG here, the profile looks good, but you'll see it's very large. And so if we pick this one, it'll say your path has been resized because it found that it was too large, and basically has some maximums here. These are still really, really big. So you probably don't want it this big, but it will at least not air out on you. This often happens when you're exporting the SVG, the size isn't quite right. And there's this edit size button that I've been ignoring until now. You can actually go ahead and click on it, and now you can change the size. Oh, I didn't want this 500 across, actually I only wanted it at 50. So I can type in 50, goes ahead and resizes this. So when we go to the preview, you can now see that it is actually 50 wide. Or I want to go back, I actually want to make it, say, 125 tall, and you can continue, and now it's 125 tall. This edit size button is there on all of them. You don't actually have to have just an error. And again, there are certain editors that are really bad about exporting the right size. Adobe Illustrator is one of them, but I've heard about some others as well. So now you don't have to play a guessing game trying to get your SVG editor to spit out just millimeters. You can use this in browser resizing if you want. There are a variety of these little eye buttons spread through the new interface. So you can hover on them or you can click on them and they will show up. And there are different, basically, notes. So this one basically is saying that the sizes are assuming a 13% clay shrinkage. So if your clay shrinkage is bigger or smaller than this, these dimensions will actually wind up being different. If you want, you can use Pro Mode to actually go ahead and select your clay shrinkage factor, and I'll talk about that in a minute. Let's go ahead and run with this one. So I think those sizes look good, so we continue to the preview. Okay, it's fine. Here's another little eye button. So this one is also saying that you can specify your own wall thickness. At the proof stage, we're estimating the volume of the pot. And to do that, we need to know how thick the walls of your pot are. So what you're doing is you're drawing the outside profile of your pot, and then we need to inset it by a little bit to figure out how much space is in the middle. And the software is doing this automatically. It's a slight approximation because the way the slip works isn't exactly a straight offset. For instance, it gets rounded off a little bit in the bottoms. I've set this in the software to be 4.5 millimeters. I tested a bunch of my pots, and it's kind of where mine are. And it's using that to estimate the interior volume. So for instance, if you want a 16-ounce coffee mug, you can use this volume estimate. Small changes in the wall thickness can actually have a rather significant impact in the volume of your mug. I have an older video testing just that, where just a few tenths of a millimeter and changing that will actually change the volume. So that is an option you can set. However, I've removed it from the basic version. Basically, I wanted to go ahead and make it as simple as possible to go from start to finish and create your molds. There are a lot of folks using ShapeCast that are new in various ways. They're either new to slip casting, maybe they're new to clay, maybe they're new to 3D printing. So I just wanted the basic set of capabilities that you can get some functional molds out. They may not be exactly the size you want, but if you're new to doing this completely, just getting some functional molds is really a win. If on the other hand, you are more advanced, and you want to really dial in your mold so you can dial in your pots, those are all gated on the Pro feature. So there's this link here where you can click on it, and it talks about the things you can get with Pro. So you can change the clay shrinkage, the wall thickness, which we just talked about, and I'll talk about file formats and some other options in a second. All right, so this looks good. Let's go ahead and submit it. If you want, while this is doing its thing, you can go back and check your other designs. This will get updated. Basically, it's polling the server. This one we don't want, so let's go ahead and delete it. So you can see that it's actually in the deleted designs now. It's processing the models. Oh, it looks like I have a bug here. If you find any bugs, definitely let me know. It shouldn't be showing right now. This was a rather complicated rewrite, so I'm sure there are a few corner cases. I think it all works correctly, but there may be a few little oddities here and there. So if you find one, go ahead and email me. I'd appreciate it. All right, so again, here's the note about the estimated volume. You can download your proof, and if you like it, go ahead and approve. So this is actually relatively big, 30 ounces, almost 900 milliliters. There are a variety of mold configuration parameters. So one, I skipped over this, but this is the name. This is actually the name of the SVG. So you can name your pots and they'll show up. And likewise, the names for all the designs are out here on the overview. So these are the names of the SVGs originally, so you can keep track that way. All right, let's go back to our Flexus Novus example, and I'll talk about Upgrade to Pro. So if you click on this button, you will see all the options you'll have available. You can go ahead and click Upgrade, which will take you to the payment link. So we'll jump back earlier in the process. At this point, you'll have options to change some of the parameters that were hidden before. One is the wall thickness, but depending on your own process, you might have thicker or thinner walls. So if you want, you can say bump this up. So I have thicker pots at 5, or I'm going to cast mine really thin at say maybe 4. You can also select the model type. So there's default STLs, high resolution STLs, step files, and both. So let me talk a little bit about these file formats. STLs are meshes. Basically, these are a bunch of triangles that represent the geometry. By default, ShapeCast is using a built-in algorithm to go ahead and create the STLs. And usually these look pretty good, but if you zoom way in, you can see there's some weirdnesses going on here. So like this little bit of shadow. These features are usually really, really small, and you probably won't even notice them, or they will be barely noticeable. This is relatively quick to generate, but it does have some of these disadvantages. I did a deep dive into this myself, and I found another way to generate STLs that are much higher resolution. So they'll have a much higher triangle count, but the triangles themselves are actually created in a much better way, so they represent the surface better. So if you have a design that for some reason just didn't quite work out in the default mode, or you really do want to have the best possible print, the high resolution STLs can be used. However, these do take a lot longer to process. Like the normal ones might take, say less than a minute, 30 seconds. The high resolution ones might take several minutes to process. So just be warned about that. They're just much more computationally expensive, which is why it's gated. So that's the high res STL. Step files. These are actually CAD files that get created. So if you have something like Fusion 360, if you ever try and open an STL file, you wind up with this mess because it's basically opening all of those triangles and doesn't really know what to do. A step file, however, is representing the solid's geometry exactly. It's using something called brep. If you wanted to open this in your CAD program and make some modifications, for instance, maybe add your logo as a stamp to the bottom or slightly tweak the geometry, you could do that in your CAD program with the step file. There are other software that manages STLs directly. Blender is one of those. So you can't really open a step file in Blender, but you can't open an STL. So depending on your own workflow, if you are good at 3D modeling, either in the mesh world or in the brep world, both of these are available. And there's an option to create both as well. So I'll go ahead and do that so I can show you. So we'll submit it with this thinner wall thickness. That means the volume will go up. Down here, you have more options. You can see the model type now is at both and the wall thickness that's being used. This will take longer to process because of the model types. So now I have a new estimate on the volume, and it knows that you use 4 millimeters instead. So it took that into account. We can download the proof. And you'll see the proof is both in the STL as well as the step file. And we can go ahead and open the STL. And if you zoom in now, it's unlikely you'll see any artifacts. Like this mesh is really, really good. All right, that's the proof. I like it. So I'm going to go ahead and approve this, get the new volume estimate, and now we have a bunch more options here. So have the outer molds, yes and no, just like before. The clay shrinkage factor. This button here will reset the shrinkage factor or the wall thickness, in this case back to 13%. So if you have a 10% clay shrinkage or 15%, you can go ahead and change this. There are also instructions on how to calculate your clay shrinkage factor. Basically, you need an original mold and a fired piece and measure the differences between those. One quick note, you can't just add the shrinkage factor onto your pot if you want to account for it. So let's do this with some money to make an example. So I have something for $100 and it's 20% off. Let's say it's a 20% shrinkage factor. So $100 minus $20, the 20% is 80. So if I wanted to reverse that, I can't just add 20% back. 20% of 80 is 16, so 80 plus 16 is 96. I didn't get back to 100. Luckily, ShapeCast does that math for you. So there's some option for flange ridges. So between all the mating faces for the molds, there are these ridges and grooves that are in these flanges here, these parts that stick out from the mold. And I've done a lot of work to go ahead and make these so that we can easily attach and demold the pieces. If you turn the flange ridges off, these will go from ridges and grooves to just flat. I'm not too sure why you would want to do that on the outer molds, but if you want to, you can. Some people have asked about it. I think if you're using the inner mold by itself and not using the outer molds, for instance, you want to use coddle boards or a bucket, there it might be useful. You could turn the flange ridges off and then this would just be completely flat. So for instance, you could go ahead and caulk it down to something and then build your own structure around it if you wanted. Again, I think that's an advanced feature. Most people won't need it, but it's there if you really want it. And then finally, there's an option for slip well. So you can have none, regular, and tall. Regular is what you get by default. So this region here is the slip well. It's between the rim of your pot and it goes up so that you can have excess slip. So as the water gets absorbed and the level of the slip goes down, it always stays above the level of your rim. So you have a nice clean rim. You can basically just trim straight along this. And this is the corresponding feature in the mold itself. So going to double is relatively straightforward. It basically makes this twice as thick. So you line it with a slip well that's twice as thick. Some forms would benefit from having more slip, just the way they absorb the slip. So that was requested by a few folks, and so I added that. And you can also turn the slip well off. In that case, this will just be flush. There's no extra plaster on the top. Likewise, the mold will just stop right there. And if you go way back in my videos, well over a year ago, I made a sphere, and the bottom half of the sphere is made with no slip well. So it's basically just flush here. I went ahead and drilled some holes in it. I was doing some tests. You wouldn't get those, but basically the edge of the pot comes up and it's completely flat. This is one way you can actually get two-part molds. It still requires a little bit of a workaround, but if you want to stack two molds on top of each other, the zero slip well could be useful. So I'm going to go ahead and create the outer molds. We can change the clay shrinkage. Let's say it's 13.5%. And let's go ahead and make the tall slip wells. We can submit this. You can see all the parameters are down here. It's going to go ahead and send this off the server. And again, it's going to take a while because we're doing the model type of both. If we go out to the overall designs, you'll see there's a little star here. These are the ones that have been upgraded. So if I click on this one down here, you can see that it was processed with a wall thickness of 4.4 millimeters, 13.1 as a clay shrinkage, and everything else was left as normal. All right, it's been a couple minutes and it went ahead and finished successfully. So we can go ahead and download our new files. These are a fair bit bigger, and you can see there's both the step and the STLs. So for instance, we can open the inner STL. There it is. It's nearly 1 million triangles, but it looks really, really good. So again, if you wanted, you go ahead and open this in Blender or your favorite CAD software, do whatever you want to it. You can do the same thing and open the step file. The step file actually gets converted by the slicer going in, so it's usually lower resolution. You can crank these up, but it can take a while. And even then, the mesh isn't as good. And here's an example. So this is just the slicer doing its thing, but you can see some of these artifacts. These are what will show up in the regular version of ShapeCast, but usually they aren't that bad. Oh, and then we forgot to look at the slip well. You can see that it's taller than it was before. The outer molds basically look the same, and they just account for the taller slip well. So if you want, you can go ahead and open the step file in a CAD program. So this is FreeCAD, but it'll work with Fusion or Rhino or any of your other things. And you can see the model and see these are actually just big planar faces. So they're much easier to deal with. Otherwise, everything else is basically the same. The readme is the same, etc. Just it accounts for all the different numbers. And when we're done, we can leave it either as an active design, or if you want, you can go ahead and move it over to archived. And then it's gone and hanging out over here instead. And you can see that was upgraded. So that's the brand new ShapeCast and the vessel design component of it. Basically, it's bringing the vessel design part in line a little bit more with the pre-built vessels and handles. Visually, this is more mimicking the pre-built vessels. These are all nice fancy renders. And the handles, for your designs, it's just the profiles. Oh, I should mention that on the overview, you also get some information. So if the volume's been processed, it'll tell you that, both in milliliters and ounces, and I'll give you the diameter and the height as well of your piece. So if you have several that look kind of sort of the same, you can tell them apart that way. And there's the status of where it is in the processing as well. I think that's all of the new features. It was definitely a big, heavy lift to get here, and I'm sure there are a few bugs lurking around, but hopefully they are all minor. All the back-end stuff is basically exactly the same. So the way the 3D models are being generated is the same. However, there are these new parameters, and those really haven't been exercised. And some of the glue code between the front end and the back end also changed. And now with this in place, I will now have a little bit more free cycles so I can go ahead and do some new things with ShapeCast. If you have any questions or comments, let me know. Thanks.